Hello students, in today's video I am going to teach how to find the support reactions of a given beam. As you can see here, the question is written on the board. Calculate the support reaction of the beam shown in figure. This is a simply supported beam. I hope you know what is simply supported beam. A beam which has supports at its ends. This is a beam. The horizontal line acts like a beam. If it has two supports at its ends, then it is said to be a simply supported beam. Now here a simply supported beam is given, and here this support at point A is called as a roller support, and at point B the support is called as a hinge support. On the beam there are three different loads. One is a point load or a concentrated load of 10 newtons magnitude. Then a UDL is there, that is UDL means uniformly distributed load. The value of UDL is 15 Newton per meter, and another point load of magnitude 15 newtons. Now you have to find the support reactions of this beam. How can we find the support reaction of this simply supported beam? The reactions which will act here at the end supports, that is A and B, you have to find them. So before starting the calculation part, what you have to do, you have to draw the free body diagram of this given beam. What is the free body diagram? So let us draw free body diagram. Free body diagram. Free body diagram means FBD is the short form. It is the diagram which shows only the forces acting on some body. Only forces. So first of all, see here at A support is there. We have to calculate the support reaction there. So it will act in the opposite direction to the forces which are acting on the beam according to Newton's third law to keep the body in equilibrium. So to keep this simply supported in equilibrium, obviously since the forces are acting on the beam in the downward direction, so the support reaction will always act in the upward direction. Okay, so here in this support A, the reaction force will act RA. Let the force be RA. Then this 10 Newton point load is acting at a distance of 2 meters from this left hand support, that is A. Again a 15 Newton load is acting, point load, at a distance of 2 meters from the right hand side support, that is B. And at B, since the support is there, again a reaction will act. Let this reaction be RB. And the distance of this 15 Newton from B is again 2 meters. Now see, the third load which is acting on the body, on the beam, is a UDL, uniformly distributed load. Whenever you draw a free body diagram, we have to convert the UDL into a concentrated, that is point load. How to convert the UDL into a point load? You have to do one thing, only just multiply the magnitude of the UDL. What is the value of this UDL? 15 Newton per meter. Multiply the magnitude value with its span. Only the span of the UDL. The length of the UDL here is 3 meters. So multiply these two values, 15 into 3, you will get 45. So 45 newtons is the point load which you are getting, equivalent to this UDL. Now where this 45 Newton point load acts on the beam, so you have to show that this equivalent force of 45 Newton point load of this UDL, 15 Newton per meter of span 3 meters, acts always at the mid span of the beam, of the UDL. Okay, always remember, whenever you convert a UDL into a point load, the point load will act, the equivalent point load will act at the mid span of the UDL. The span of the UDL is 3 meters. So mid span means at the half distance of this, that is 3 divided by 2, 1.5 meters. So this 3 meter span will split it into 1.5 and 1.5. Okay. So let me show this here. This is 1.5 meters. This is also 1.5 meters. Okay. So two things you have to remember. One, always while you are drawing free body diagram, always convert a UDL into a point load. How can you convert? Multiply the magnitude, that is the value of UDL, into its span. Here it is 15 into 3, that is 45, and locate that 45 Newton point load at the mid span of the UDL. So whatever is the length of the UDL, just at the midpoint of that UDL mid span, that is one, here it is 3 meters, so the mid span is 1.5, 1.5. There you have to locate the point load. Okay. Now the free body diagram is completed. Let's just start finding the values of reactions, that is support reactions RE and RB. First step is you have to apply conditions of equilibrium. So applying conditions of equilibrium taking moments about A. First condition you have to apply. Taking, always remember, in a simply supported beam, if you are solving and you are trying to find the support reactions, always take the first step, take the moment about its left hand support, that is A here. So taking moments about left hand support, that is A. Okay. Summation MA equal to 0. The sign convention for moment is clockwise positive, anti-clockwise negative. So let us start finding the moment. So how you have to find the moments? First of all, consider the point about which you are taking the moment, that is point A. Now see how many forces are acting on the beam. You have to consider both the loads which are acting, also the reaction which is acting on the beam. So if you count, if you see here, there are 3 loads, 3 point loads and 1 reaction load. Now you have to find the moment of all these 4 forces. So first of all, consider this point load, 10 Newton. We'll start from here and we'll proceed in this fashion from left to right. First of all, consider 10 Newton point. It is acting downward. What you have to do, always, whenever you try to find moment, turn that force. Try to turn that force towards the point about which you are finding the moment. Here we are calculating the moment about point A. So we'll try to turn this 10 Newton force towards point A. So what is the direction in which it is turning? It is turning in clockwise direction. So what is the sign convention for clockwise? Positive sign, plus. Now how you will get the value of this moment of this 10 Newton force? Moment means force which you are considering into perpendicular distance between the force and the point about which you are finding the moment. We are finding the moment about point A. So what is the distance between point A and 10 Newton force? 2 meters. Perpendicular distance is 2 meters. So multiply this force into this distance. So 10 into 2, that is the moment. And since it is turning in clockwise direction towards point A, so it will be positive in nature. 10 into 2, we will keep this in brackets since it is clockwise, positive. Again, now consider second force, that is 45. Now find the moment of this 45 newtons, again same point, that is point A, support A. Turn this towards A, so it will also turn in clockwise direction if you turn this towards A. So again positive. And what is, how can you find the moment? Force 45 newtons into the total distance of this 45 newtons from point A. So total distance from point A is 2 plus 1.5, that is 3.5. So 45 into 3.5, turning clockwise, this one also towards A, so positive, plus already written 45 into 3.5. Now third force 15 newtons, it is also acting downwards. You have to again find the value of this force also about point A. So it will also turn in clockwise direction. So clockwise is plus, positive sign, and moment will be this force 15 newtons and its distance from A, total distance from A. How much is this total distance? 3 plus 2, 5. Total distance is 5. 15 into 5 is the moment of 15 Newton about point A. And then the last one remaining is the support reaction at B. Now see the direction of support reaction. This is acting in upward direction. So if you have to find the moment of this force about point A, since it is acting in upward direction, if you turn this towards A, it will turn in this fashion, that is in anti-clockwise direction. It will go like this. So since it is turning in anti-clockwise direction, the sign will be negative, minus, and the distance, total distance of this force, reaction force RB from A is this entire distance, length, that is 7. So minus RB into 7. Why negative sign? Because this force is turning in anti-clockwise direction towards it, is equal to 0. Okay. So now after calculating this, you can calculate the value of this much in your scientific calculator, and the value of this you will be getting 252.5, and this one remaining is minus 7 RB. 7 into RB, 7 RB equal to 0. So 252.5 is equal to, bring this minus 7 RB towards right side, so it will become plus 7 RB, and bring this to this side, this will divide this, and you will get the value of RB. So RB is equal to 36.07 newtons. The value of RB is 36.07 newtons. Okay, so we got one reaction, support reaction. Now second reaction is RA. So let us find that also. Now we will consider second condition of equilibrium. So the second condition of equilibrium you have to consider is, since all the vertical forces are acting on the beam, since the forces are vertical acting in downward direction, and the reactions are also vertical acting in upward direction, so applying the condition of equilibrium, second condition you have to apply is summation Fy. Since all the forces are vertical, so summation Fy will consider. So the sign convention for this you have to take is upward force is positive, downward force negative. This is very simple to solve. See, you have to just add all the forces which are acting on the beam, starting from the, in case of simply supported, starting from the left hand side. Always remember, you have to start from left to right. Now first force is RA. What is the direction of RA? Upward direction. Upward is positive, so RA positive. Then next force is 10, downward direction, minus 10. 45 downward direction, minus 45. 15 downward direction, minus 15. Since downward is minus, that's why I have taken minus, minus, minus. And again RB is upward, so plus RB is equal to 0. So this is summation Fy. Now RA remains same, minus 10, minus 45, minus 15, plus RB value we just calculated, we got it 36.07. Put the value of RB here is equal to 0. That is equal to RA minus, when you saw this much in your calculator, you will get the value 33.93 is equal to 0, and bring this towards right side, therefore that is equal to minus 33 will become plus 33.93. So this is second support reaction, that is reaction at A. Okay, in this way you can find the support reactions of the beam.